Welcome to Unit 3, Section 3, solving multi-step equation. Multi-step, what does that mean? Multi-step, it means you have more than two steps, and so this can get a bit tricky. We're going to have to keep in mind all of our inverse operations, basically the opposites of each operation, so the opposite of addition is subtraction, so on and so forth. You already know that. I'm not going to bore you. Here's how we're going to solve these multiple steps. We have lots of different tools, and sometimes you can do things a different way, and as long as your way is communicated thoroughly and we know what you're doing and it's proper, then we'll give you credit for it. You cannot just pull an answer out of the air, though, and expect to get credit and say, well, I got the right answer, doesn't it? No, you can't do that. We have to see the process. We're grading the process here. So here's what we need to look for when we're solving these equations. We're looking for combining like terms. Okay, that's one thing we're going to do. We're going to use some reciprocals. We're going to apply the distributive property, and we're going to use all of these inverse operations that we talked about before. How fun is that? That is fun. Here's the first example. -2 plus 3x equals 10. All right, so my suggestion is always, is there anything you can do to make it more simple? And usually, if you can combine like terms, that is the best thing to do right off the start. You want to combine some like terms. So remember, like terms, numbers with numbers, so like 2 plus 7, those are like terms. If they have a variable, then you can combine those, 2x plus 7x. Okay, so this would equal 9, this would equal 9x. All right, can you combine a 2 with a 7x? No, because they're not like terms. All right, so we're looking for like terms. Let me get rid of that. And the like terms here, I'm going to circle them here, or underline them. Let's underline them. 3x and 3x. Let's just combine those. So 3x plus 3x, or say 3x's plus 3 more x's, that equals 6x. So we get -2. So the -2 comes down, plus 6x. Combine those first. And now look, now we have a very simple two-step equation. Here's the x. We have to get rid of this 2 over here first. All right, if you want to rewrite it like this, I'm going to rewrite it like this. You can. Look, I just switched these two. Now, do you have to do that? No, you don't. But if you want to, you can. You have to be careful, though. Here's my little warning. Remember, this 6 is positive. So if you rewrite it, then the 6 has to stay positive. And the 2 is negative, so we're going to write -2. That's a -2. All right? Let's pretend like we didn't do that, though. How would you solve this equation? You got to get rid of the 2 first. So we're going to add 2 to both sides. And remember, Mr. Brust likes this line right here down the middle. So, like, students sometimes will say +2, and they'll put a +2 under the 6x, and that's wrong, because here's the equation. You got two sides, the line divides it, and you have to have a +2. You got to do the same thing on both sides of the equation. So that's where that line helps us out. All right, so -2 plus 2, they cancel, and here we get 6x is equal to 12. Well, now we can divide. What's the opposite of multiplying? It's division. So we'll divide, and we'll get x equal to 2. Hey, how about that? How would we check it out? Plug a 2 in here. I'm going to do it real quick. -2 plus, well, 3 times 2 is 6. So -2 plus 6 plus another 6. 6 and 6 is 12, plus a -2 gives you 10. So that works for us. The check works out for us just fine. How about this one? Here's a little hint. We're going to use the distributive property. Ooh, remember what that is? Swoopy swoopies. 2.5. So, as we swoop, what do we get? -2x. We have a -2 times a -4. That's a +8. Okay, the distributive property ends there because that's the end of our parentheses. So this -5 just comes down, and this is all equal to 3. Let's draw that line. Okay, now what? That was the distributive property. What can we do here? What can we do? What can we combine like terms? I like combine like terms. Here we go. Look at those two. We have a +8 and a -5. So we're going to get -2x. We have +8 minus 5. That's a +3. And this is all equal to a 3 on the right. Now what? So how are we going to get rid of this? You passed that mastery check already. You know what to do. Subtract 3 from both sides. We get -2x equals 0. And when we divide by -2, what's 0 divided by -2? 0. 0. X equals 0. If you want to plug it in and check it, you can, but we're going to move on. How about this? Solve the following equations by using a reciprocal. Ooh. Well, I'm going to rewrite. I'm going to switch these two. Look. Can I rewrite this a different way? I usually don't do this, but I'm doing it to show you can, because some students like it. They have their order they like, and they like the variables on the left. Alright, so I just switched the order. Now it says we're going to solve this by using a reciprocal. Did part of your brain go, hey, I want to do the distributive property? You can do that, but look, if you distribute this 1/2, it's going to be a half times -3. You're going to get -3 halves. That's ugly. I have a better way to do it. You can use the reciprocal to get rid of the half. So remember, this is really 1/2 times blah, blah, blah. A whole bunch of stuff in the parentheses. If we're going to multiply the parentheses by 1/2, how would we undo that? The opposite of that would be times 2/1. That's the reciprocal. If you remember, reciprocals are when you flip it. You got to flip the fraction. Flip. Hey, where'd my eye go? Flip. Okay, and so if you multiply, here's our line, remember, and if you multiply the left-hand side of the equation by 2/1, then you have to multiply the right-hand side as well, and that'll keep the balance. Well, what will that do? 2 cancels 2, and 1's canceled 1, so you're left with a whole bunch of 1's all over the place. You get -3 plus 3n. I don't need the parentheses anymore, because all of this cancels to 1. It's 1 times this. Well, 1 times anything is itself, so I can bring that down. 18 times 2/1, that's just 36. And look, that's a very simple equation. You're not dealing with -3/2 and -3/2n and ugly this and ugly that. You have a very simple equation here. We just need to get rid of the -3. So we're going to do a +3. +3, both sides. And we get -3n equals 39. If you divide each side by 3 at that point, you're going to get n equal to 13. That is fun stuff. So we did combining like terms, and we used a reciprocal. You guys are excited. All right, let's do this problem. I love it because of all the negatives. I mean, don't get me wrong. I don't like being negative, but look, negative, negative, negative. 3 negatives in one problem, and that's just, oh, I love that. That just makes me so happy. But there are several ways to do this. So I'm going to show you 2 different ways. Let's draw a line, and let's do it 2 different ways here so you can see that you're going to get the same answer either way. It doesn't matter how you do it. First way, I'm going to do the distributive property first. So distribute here. Alright, so I like this problem because when you distribute, you have to make sure that's a -6. And teachers love to give problems like this so that you're remembering this will give you -6x or -6x. And it'll give you a -6 times a -4. That's a +24. All that equals 31. Okay, now what? Now we have 3 terms on the left. I mean, there's got to be bells in your head going, hey, 3 terms? Let's put some of these together. Let's combine some. So the -5 and the 24, they can combine. We're going to get -6x plus 19. This is the same as 24 minus 5. So you can do that right in your head there. All that equals 31. So now what? Subtract 19 from each side. Alright, 31 minus 19 is 12. So we get -6x equals 12. We divide by -6, and we're all done with that one. We get x equals -2. Make sure you box that answer there. Equal signs are all lining up. Okay, we did a good job. That was using the distributive property first. That was the first step. Alright, now check this out. I'm going to do this one a different way. And this is probably how I would do it. If I were solving this off to the side somewhere, I had to solve an equation, I would probably get rid of that 5 first. Now, like, you can do that, Mr. Kelly? You can get rid of that 5 first? Look, it's -5 minus blah, blah, blah. Let's get, if you add 5 to the left-hand side, the -5 and the +5, they'll cancel out. So you're going to be left with -6 times x minus 4 equals 36. Hey, that's a lot simpler than this equation right there. Maybe you don't agree. What I'm going to do next is I'm going to multiply by the reciprocal. Now, yeah, you probably would distribute here, but watch. What's the reciprocal of -6? Well, it's 1 over -6. And how, if you multiply both sides by that, try to squish that in there, these cancel out. You get 1's. So there's nothing. It's 1 times x minus 4. That's just x minus 4 equals, and remember that's a -6. I know my handwriting's terrible. 36 times 1 over -6. That's 36 over -6. That's just -6. All right, they kind of cancel out. They'll give you 6. That'll give you a -1. So you get -6 there. Now look how easy this equation is. It is so simple. Simplicito. There you go. Voila, you get the same answer. So, what's the moral of the story? This is actually a fable. This goes way back generations. Moral of the story: as long as you're consistent with what you're doing to both sides, like here we added 5 to each side, and you're consistent in combining like terms, it doesn't matter which way you do it. You can do it either way. You could probably do it a third different way. I mean, if you wanted to distribute here, you'd end up getting the same answer. Just you have to show all your steps, and you have to justify your answer. We're not making you do the checks because we're going to make you show every single step. So that is it for Unit 3, Section 3. Remember, it's nice to be important, but it's more important to be nice. Good luck on that mystery check.